just jump right in. So discovery project, the geometry of a tetrahedron. So a tetrahedron is a solid with 4 vertices, P, Q, R, and S, and 4 triangular faces as shown in this figure like this. And throughout this video, I'm actually going to be dealing with a pretty much a rectangular triangular setup here, or just a perpendicular setup. Here we're at this center point S. Is all the angles are right angles. I'll be dealing with that. But yeah, this is basically a tetrahedron. Is just a triangular pyramid. All right, so let's just jump right in. And yeah, let's look at question 1. So question 1, so let V1, V2, V3, and V4 be vectors with lengths equal to the areas of the faces opposite the vertices P, Q, R, and S respectively. So in other words, so if we have this right here, make this a bit smaller. All right, so we have the vector V1. It's going to be opposite of the face, or actually it corresponds to the area of the face opposite the vertices P. So if this is P, the face opposite is going to be right here. So the length of this vector is going to be like that, V1, and directions are perpendicular to respective faces and pointing outwards. So if it's perpendicular to this face, then that means, and it's pointing outwards, well, we're going to be pointing away from it, and let's set everything to the origin. We're going to be pointing downwards away from this face and then perpendicular to that, and perpendicular to that setup. All right, and then V2 is going to be corresponding to the face opposite of Q. So if this is Q, the face opposite is going to be this. So in other words, this is going to be your V2, the length of it, so you put the absolute value sign. And the direction is moving outwards or away from the tetrahedron and perpendicular to this face. In other words, it's going to go over this way. And then V3 is going to be opposite of R. That's opposite of R. So it's going to be over here. That's V3. And then the direction is going to be opposite of it. It's going to be pointing outward. Like that. And then the last one is V4 is opposite of S. That's going to be this entire PQR triangle. That's think of it in 3D, basically the one facing you, and it's going to be pointing outwards away from it, basically directly across. Directly past the page, or like away from the page. In other words, right at your face when you're looking at it. Anyway, so and then we're asked to show that V1 is equal plus V2 plus V3 plus V4 as vectors. Add the vectors up equals this 0 vector. So let's jump right in. So first of all, because we're dealing with areas of the faces, which are triangles, recall that the length of the cross product is equal to the area of a parallelogram formed by 2 vectors. So therefore, half that area is the area of a triangle. So in other words, yeah, just note that if we had a vector like this, say we had A, and then we had a B vector, let's say there's an angle theta, and basically half of that is going to be, well, the area of this triangle is going to be 1/2, and then the length of the cross product. The length of the cross product, A cross B, as I showed in my earlier video. Where if you ignore that half, you're going to get the parallelogram. It goes like this. But we're dealing with half, so just set up like that. Alright, so thus the lengths of the vectors V1, V2, V3, and V4 can be written as half the cross product of 2 sides of each triangular face, or triangular face. So in other words, if you have a vector here and a vector here, then half that cross product will get this area. And that's going to be the length of one of the vectors. So let's take a look at this. Let's just draw this out in coordinate form. So what I'm going to do now is I'm going to write this like this. I'm going to draw the triangle. Well, this corresponds to the outward facing face. And let's say this point is P. And let's say it has coordinates. This is on the z-axis. Well, let's just draw the S first. So let's say that there's S right there. This goes out like that. This goes out like this. And this is all right angles, etc. And yeah, that's the right angles. Everything's right angles. Even the bottom. And let's just say this is S. And that's the origin. 0, 0, 0. That's the origin. And then this is Q, this is R. Let's say the coordinate of P is going to be the vertical axis, 0, 0, and let's do lowercase p. Like that. And then for R is going to be, well, 0, and then lowercase r, this is the y-axis. And then Q is the q is the x-axis, so they'll be at lowercase q, 0, and 0, like that. All right, and now let's take a look. So V1 corresponds to opposite of P, so the face opposite of P. That's going to be, well, this is P. This one's going to be this triangle is going to be our length of the vector V1, like that. And then opposite of Q is going to be our V2. Opposite of PQR, and so that's opposite of V2. Opposite of Q, and then opposite of R is going to be over this triangle, and that area is going to be, well, the length V3. And then lastly, the one that's going to be facing up in front of us, that's going to be just this whole PQR triangle. I'll put the V4 vector is equal to, so this V4 vector is equal to, well, the triangle, the area of the triangle P, Q, and R, like that. And now we could write all of these as cross products, and we can do that over here, because again, these are the cross products. So let's look at the V1. So V1 is going to be written as, we could write it as the cross product from SQ and then SR, or the half of that cross product. Let's write the formulas for all of them first, then we'll calculate each one. So V1 is equal to 1/2 the length of the cross product SQ vector cross SR vector, like that. And then V2 is going to be, goes 1/2, and the vector, the cross product is going to be V2, so we go SP and then SR, like that. SP cross SR, like that. And then lastly, we have, or this V3 here, we'll go from SP to SQ, like that. All right, so let's do V3 is going to go for, equals 1/2 cross product SP cross, and then SQ, like that. And then lastly we'll look at V4. That's this triangular one. So let's write this V4 length equals 2 1/2. And then the cross product will go, well, we'll look at from the top here, PQ, and then we'll go PR. So PQ cross PR. And it doesn't matter which directions you do, because you're doing absolute value. You're looking at the length, so you're going to get a positive number. All right, PQ and PR, like that. All right. All right, now that we have the equations in cross product form for the lengths of all these vectors, let's take a look at, well, calculating these each one, and we could first write that in determinant form. So we can calculate each area by first writing the cross product in determinant form. All right, so let's do the first one. So V1 there. So the length of the V1, let's write it down here. V1, like that, is equal to 1/2. And then this is a SQ, and then time across SR. So SQ and SR. SQ cross SR, like that. And now this equals to, in determinant form, I'm going to put, well, first we need this absolute value sign because we're dealing with the length of the cross product, because the cross product gives a vector. And then we put another line for the cross product, another line is for the length. And then we do the components I, so recall from my earlier video, J, and then K, so recall from my cross product video. All right, so that's what we have, and then there's another length like that. And then we put the components, or the so each of the vectors. So SQ, well, it's going from S to Q, and then so recall that to get the position vector, we just Q minus this point here. So Q minus S for each component, but this is the origin, so then basically that is the position vector. So this is going to be Q 0 0. Then the R is going to be 0 R 0. So this one is SQ is the x-axis, has a value Q. Then 0 0. And then SR, that just has the point at the y-axis, R 0. All right, so this equals 2. Let's put the 1/2. And then the next one as well, we're doing it at length, so let's put that line there. And now remember the setup, so we would cross this out, and then we'll go 0 times 0 minus 0 times R. So in other words, we'll have a 0, minus 0, like that. And that's for the I component. Now we could erase this. Now the next one is going to be, well, minus, and then we cross this, cross the center. Now we go q times 0, and then 0 times 0, that's again going to be a 0 vector. J, like that. And then the next one is going to be, well, let's erase this. We'll cross this, cross that. And this is going to be plus, and then this is, this is from here, across this one. That's going to be QR, and then 0 times 0. So we'll get a Q times R minus 0, and this is the K vector, like that. Yes, we block it off like that, erase this, and now we have this, and all these vanish, so we're just going to have a 1/2, and then the length of the component QR K vector, the standard basis vector. This equals to, well, just write this in the other format that we're used to, just so we don't get rid of these. This is just going to be the same thing as writing the 1/2 length from 0 component, 0 in the x, 0 in the y, and then QR in the z component, like that. And then recall the length is just going to be square root, so we'll do 1/2, then square root, and then all the components squared. So 0 squared plus 0 squared plus QR squared. Then all these vanish, and then this square root cancels the squared. We're just left with 1/2 QR. So that is the length of the component. And note that it only has value in this Z component. So that's the only part it has, and the length of that is going to be, well, 1/2 QR, and you can just multiply that inside. And now if you look at the direction, and that's where I've written here. So since we are told that the direction of the vectors point outwards, perpendicular from the faces, then the vector v1 must be pointing downwards away from the tetrahedron. Yeah, so we have our cross product is this. So and the length of it is going to be this one here, and we're told again that the length of that cross product, or the half that length, is going to be the length of that vector. So that gives us a clue as a direction. It's going to be on the z component, and notice the face right here. So that's this one right here, and it's going to be pointing downwards, perpendicular away from the tetrahedron or away from the face, be downwards like that. So if it's pointing downwards, and then the length is going to be this, then we could just, well, plug that in for the z component. So what we have is v1 vector is equal to, well, basically this one here, but it's pointing downwards, so negative. 0, 0, then negative 1/2, multiply the 1/2 inside QR, like that. And there is our direction. Yeah, so there's the vector with direction there. Alright, so going further, so similarly for the remaining 3 vectors we have, so let's write v2 now. And again, write it a bit more down, because we're going to write the determinant form of the cross product. So v2, the length of it is equal to, well, 1/2 in the cross product, and it's what right here, SP cross SR. So SP as the vertical, and then SR here to get this v2 there. And then, so SP and SR, those are the coordinates. This is the Z1 is the Y1. All right, so SP and SR. SP cross SR, like this. This equals to 1/2, and then the cross product. So we'll put a length like that, and then the determinant form. So I, J, K, like this. And then put the determinant, and then the length. And then IJK, so the P1 right there, that's going to be, well, the Z component 0, 0, P. And then the R is the Y1, so 0, R, 0. All right, so let's just solve this cross product. All right, so let's just write this down. So 1/2, and then put the length or the absolute value sign. Then do the same setup as before. Cross this, cross that, and then this times this, minus this times this. That's going to be, well, 0 minus PQ or PR, like that. And then this is going to be I component. And then the next one's going to be minus, erase this. Well, we could keep the top one actually always on there. And this next one's going to be across the middle, and that's going to be 0 times 0, 0 minus P times 0, 0, and then J, like that. And then next one's going to be, well, erase this. It's going to be this one right here. So that's going to be, well, again, another 0 times r, 0 minus 0 times 0, 0, okay, like that. And then put the length sign like that. All right, so that's what we have. And everything vanishes except the first term. So we're left with 1/2, and then 1/2, and put the length like this, negative PR, and then I component. And then in the other setup that I like is, just put the 1/2 there, just keep it out of there. Easier to write. It's going to be, we'll also forget to put the absolute value sign or the length. So negative, and then this is going to be negative PR, and all the other terms are 0 and 0 for the Y and Z components. And like that. Alright, so that's what we have. And now plug this into the length formula, the square root, and we'll put the 1/2 outside. And then each term squared, so negative PR squared plus 0 squared plus 0 squared. And yeah, again, we're dealing with the absolute value sign, so you could go with negative right here squared would be positive, and then we're just left with PR, so this will cancel, etc. And we're dealing with absolute value sign, so it's going to be 1/2 PR, like that. And all the other terms get out. So it's the absolute value is that, or in other words, the length. And now the vector v2 is going to be equal to, well, it's going to be, let's take a look. So notice that the cross product only has it in the x component. And if you look at the face right here, so there's the face, there's the area, and it's going to be perpendicular and pointing outwards. In other words, it's going to be pointing outwards this way. Perpendicular to it, will start from the s value, and it's going directly opposite of q. I mean, or the directly opposite of, q, this face, and this x-axis there. So basically, it's going to be just this thing. So in fact, this cross product is actually the same direction that we are going to have. Then put the negative 1/2 inside. It's going to be negative 1/2 PR, and all other terms are 0, like that. And then when you take the length of this, you're going to get this right here. All right, so circle this. And now the next one is V3. All right, so let's do the length of V3 is going to equal to 1/2 the cross product of, well, SP and then SQ. So that's V3 is over here, so SP and then SQ. Let's write this down. So SP and then cross SQ, like this. And now this equals to 1/2 and then length determinant I, J, K. All right. All right, so we have that. And the components P is going to be, well, 0, 0, P. And then the components the coordinates of this Q there is going to be, Q is just Q right here, 0, 0, because P is the z-axis, Q is the x-axis there. And now, all right, and now what we'll do is the same thing as always. So this equals to 1/2 length, and then let's take cross this out, and then block this out. So 0 times 0, and then P times 0. It's going to be, well, 0 times 0, 0, minus 0 times P is 0, and then this is going to be I, like that. Block out I, and then minus, and then this is going to be erase this one here. So 0 times 0, and then minus P times Q. 0 minus PQ, like that. And then this is going to be I. And the next one's going to be, let's block this out, like this. And then the next one's going to be plus, erase this line, cross this out. So 0 times 0, those are all just zeros. 0 times Q is 0. And that's the K component, like that. All right, so we have this and we have that. And then everything else vanishes, so we're going to get 1/2 and then put the length like this. This vanishes, and this one becomes negative, and the negative becomes PQ, and then J, like that. And then the other one is 0. So the length of that, just write this in the component format here. This is going to be, well, 0. Well, again, we're dealing with length. So we're doing the length of that. And then this is PQ, and then 0. Like that. And then take the absolute, or take the Pythagorean theorem, the triangular one, to get the length like this. This is going to be, well, 0 squared plus PQ squared plus 0 squared. So the absolute value of the length is going to be, yeah, then this all cancels. We're just left with 1/2 PQ. So that's the length. And to get the direction, we know it's opposite of the face. So, and V3 vector is equal to, this is going to be equal to component like that. And notice again, from this cross product, it only has the y component, and that is actually what we also just need. So we have it here. It's opposite of this face and pointing outwards. So it's going to be pointing this way, perpendicular to it. And that's going to be directly parallel with this y-axis. So that's going to be minus PQ. Let's just erase this and erase that. Let's make it neater. Yeah, so directly opposite of that. So that's the length. We're just going to go this right here. Put a minus sign and also put the 1/2 inside. 0, negative 1/2 PQ, and then 0. Like that. Box this whole thing in. All right, and now note that for the length of V4, put a bold here. This one, since it involves vectors not relative to the origin, we need to calculate the position vector, which is again the equivalent vector but starting from the origin and is the difference in each coordinate component. So it's going back here. So this is going to be V4's 1/2 PQ PR. So PQ PR is like this, and then PR is like this. So notice that none of these are starting from the origin, whereas all the other ones we had were starting from that origin. It's jumping up over here. Put a dot. So all the other ones were starting from the origin, from the origin. So to get that equivalent one to the origin, we just take the difference. So we'll go Q minus P, and then that will be the equivalent. So if this is the vector like this, it's going to be the equivalent vector here, and so on. And then this vector here, QR, for example, or PR, is going to be shifted here. So this vector here, we can shift it here by taking the difference. All right, just erase this. All right, erase that. And let's scroll down here. All right, so let's write this down. So V4, the length, is equal to 1/2. The cross product, again, the cross product for this one is PQ, PR. So PQ and then PR. So we'll do the position vector. So Q minus 0, 0 minus 0, and then 0 minus P there. And then, yeah, PR, and then R minus that there. So let's do PQ and then PR. And let's see if we have that correctly. Yeah, PQ, PR. All right, so PQ cross PR. This equals to 1/2 the length. Then there's a determinant. Put the I. Let's make more room because we'll be doing some subtraction. J, then K, like this. Length. Determinant and then length. Do that again. Determinant, length. All right. So PQ. So Q minus P. Q only has terms in the X component, and P only has terms in the Z component. So put a minus P here. So minus 0, 0 minus 0, and then 0 minus P. And then the R only has components in the Y one, and that's going to be R's here. And we're doing R minus P. Then P only has it in the Z, like that. And we're subtracting the other way around. So we're going to have 0 minus that, R minus 0, 0 minus 0. And simplify this out. This equals to 1/2. And 1/2 determinant, length, determinant, I, J, K, like that. Length, determinant length. This is going to be Q, 0, and then negative P. So we just subtract all these, get rid of the two variables, put 1 or two numbers. 0, R, negative P, like that. Now this equals 2. Let's put it down here to make it neater. Length, and then this is going to be cross this out, cross this out. We're going to go 0 times negative, negative p is 0, and then minus 0, minus, and then this is going to be a negative p times r, so negatives cancel, becomes positive pr, like that. And this is the I component. And now we'll do subtracted by, get rid of this, cross this out. So q times negative p is going to be negative pq minus a negative p times 0, 0. This is the j component. Now the next one is going to be plus, get rid of this, cross this. So we're going to have qr minus 0 times 0, 0, and then this is k. Like that. That's fascinating stuff. And then put the length, right, this dot here. Alright, so we have that. So this equals 2, simplify everything, cross like that. So length, PRI, then minus cancels, becomes PQJ, like that. And then plus QRK, like that. And then just for completeness, because the other one we wrote it all in the component format, as opposed to the standard basis one, but even though this one's pretty straightforward, it's going to be PR, PQ, and then QR, just because we did it for all the other ones, and it's be length, length. So this equals 2, 1/2, and then the square root of everything, PR squared, and then this is going to be plus PQ squared plus QR squared, like that. And yeah, we could just keep it like that. That's pretty straightforward. So that's the length. And now the component of it, and the vector itself is going to be equal to, well, so we have this number, the cross product is there with the 1/2. And notice in all the other ones we did, the cross product basically is the exact same vector, but we had to choose a direction based on what we were told. So this one here, if we look at this face PQR, like that, so basically we're going to have to go outwards from it. So in other words, this is going to be pointing outwards in a positive direction as opposed to the negative. It's either positive or negative, and in our case it's going to be positive. So notice all these other ones we just took accordingly. We took this one's going to be negative. This one we took positive. This one's also negative. Then the V3 was was negative as well. This one is positive. So the only one that's actually positive is this one. So all these are going to be positive. So we'll just put these all down and multiply the 1/2 inside this cross product setup there. This is going to be all positive. So 1/2 PR, 1/2 PQ, 1/2 QR, like that. Alright, box this in. Alright, so now that we have all these vectors, note that the vector V4 is pointing out of the page in the positive direction away from the PQR triangle. And yeah, so now therefore if we add all the vectors we get, so let's just write these down. So V1 vector plus V2 vector plus V3 vector plus V4 vector, like this, equals 2, and this is going to be blank. Not blank, that's going to be the component there. So let's write the V1, it was above here. So V1 is 0, 0, and then negative 1/2 QR. Alright, so this was 0, 0, then negative 1/2 QR, like that. And then put a bracket like that. And we're going to be adding, so this is going to be plus, the next one is going to be V2, is negative 1/2 PR and then 0, 0. This is going to be negative 1/2 PR 0, 0, like this. And just put it like that there. And here I just made this big space there because I want to try to make it line up somewhat. And now the next one is going to be, well, plus V3, and V3 is right here, 0, 1, then minus 1/2 PQ. And then 0 there. So 0 minus 1/2 PQ, and then 0, like that. The next one is going to be, well, this right here, 1/2 PR, and then 1/2 PQ, right here, and then 1/2 QR. So notice what happens here. All these cancel out. So this cancels with this. This cancels with this. And then this cancels with this. Yeah, so these all just cancel. In other words, we're just going to get left with a 0, 0, 0. In other words, the 0 vector. Epic stuff. And yeah, if we scroll back up, that's exactly what we were asked to solve. And that's right over here. So question 1. So we were given these vectors with these conditions, and we showed that the summation of all the vectors equals to the 0 vector.